Exercise 15.1 from your Ncert book. In a cricket match, a batswoman hits a boundary 6 times out of 30 balls she plays. Find the probability that she did not hit a boundary. So what we can see from here is that a batswoman has played 30 balls, out of which she has hit 6 times boundary. But the remaining times she did not hit boundary. Find the probability that she did not hit a boundary. We shall keep it in mind. Let us first write down the total number of trials or total number of balls she played, and that is equals to 30. The number of times the ball touched the boundary, that is, she hit boundary, is equals to 6. Now, we have to find out the probability where she did not hit the boundary. Therefore, we should find out the number of times she did not hit the boundary, or the ball missed the boundary is equals to total number of balls played minus number of boundaries, that is equals to 30 minus 6, that is equal to 24. Hence, let the event of not hitting the boundary be represented by E. So we will represent the event in terms of E. Hence we can write the probability of E is equals to number of favorable outcomes, in this case number of boundaries missed, by total number of outcomes, that will be 30. So she missed 24 times, so it will be 24 in the numerator, and the total number of balls played was 30. Therefore, the probability of this particular event is equals to 24 by 30, that is equals to 4 by 5. Hence, we can finally write the answer. Question number 2. 1500 families with 2 children were selected randomly, and the following data were recorded. Compute the probability of a family chosen at random having 2 girls, 1 girl and no girl. Also check whether the sum of these probabilities is 1. Before we start solving, let's look into the given table. The first row contains the number of girls in a family. So there can be no girls, 1 girl or 2 girls. Number of family. So from this data we can understand that the families having 2 girls is 475. Number of families who have only 1 girl is 814, and the number of families who do not have any girl, that is 0 number of girls, is 211. From this particular data, we have to compute the probability of a family chosen at random having number 1, 2 girls. So from here we can say the total number of families or total outcomes should be 1500, as the total number of families is 1500. Out of the 1500, the number of families having 2 girls is equals to 475 from the given data here. Now we have to find out the probability that the girls or the families will have 2 girls. So the probability of selecting a family having 2 girls is equal to number of families having 2 girls, that is equals to 475 by total outcome, that is 1500. If we simplify this, we will get 19 by 60. The second part asks us to find out the probability of a family chosen at random having only 1 girl. Hence, the number of families having only 1 girl is 814 from this table. Therefore, the probability of selecting a family with 1 girl is equals to number of families with 1 girl, which is equals to 814, and the total number of families or outcomes, that is equals to 1500. Hence, the probability is 407 by 750. Number 3, the probability of family having no girl or 0 number of girls. So the number of families with no girl is 211, and hence the probability would be 211 by 1500. Now we have to show whether the sum of the possibilities or probabilities is 1 or not. As we have discussed in the previous video, that the total sum of the probabilities will always be unity or 1. Hence we can say that the total probability out of all these families, 1500 families, would be 475 by 1500 plus 814 by 1500 and 211 by 1500, because these are the values of the probabilities of having 2 girls, 1 girl or no girl. Let's take the LCM and sum it up, and hence we will get 1500 by 1500, that is equal to 1. So from this example we can clearly see that the total probability from one event will be 1. Question number 3. In a particular section of class 9, 40 students were asked about the month of their birth, and the following graph was prepared for the data so obtained. Here we can see there is a graph. Along the y-axis they have plotted the number of students, say 1, 2, 3, 4 up to 7, and along the x-axis they have written the months of the birth. That is, we can see bar graph right over here. These bars represent the number of students for each month who has taken birth in each month. So from the first bar we can see in the month of January 3 students have taken birth. In month of February 4 students have taken birth. In the month of March and April only 2 students have taken birth. In the month of May 5 students, and so on. We have to find the probability that the student of the class was born in August. So if you see from here, the month of August, it has a lot of students who have taken birth in that month, and that number is 6. So we can see from the graph, we have the total number of students born in the various months is equal to 40, because total number of students is 40 or total outcome is 40. Now, number of students born in August is 6. We can clearly see from the bar right here. Hence, we can say the probability of a student of class 9 who is born in August is equal to 6 by 40. 6 is the number of students born in August by total number of students. Therefore, the final answer would be 3 by 20. Number 4. 3 coins are tossed simultaneously 200 times with the following frequencies of different outcomes. So what we can see here is we have a total of 3 coins, and those 3 coins were tossed simultaneously or altogether 200 times. That means this particular random experiment of tossing 3 coins altogether was performed 200 times. Now, after performing it, the outcomes that has been obtained is given in this particular table. In the first row, we can see the outcome, various outcomes given over here, and these are the frequencies, that is number of times we have got these outcomes. So from the second column, we can see that we have got all 3 heads when we toss the coins 23 times. The third column shows that we have got 2 heads and the remaining one has been tail. So 2 heads and 1 tails 72 times. 1 head and 2 tails 77 times, and no head, that means all the outcomes were tails for all the 3 coins. This happened 28 times. So from this particular table, we can not only get the number of heads but also the number of tails. If the 3 coins are simultaneously tossed again, compute the probability of 2 heads coming up. So let us predict what can be the probability of getting 2 heads when we toss again. So the total number of times the 3 coins are tossed is 200. Remember, tossing the coin once or 3 coins at a time is an event. We are tossing 3 coins at a time and that is our event. We did this particular experiment 200 times. So total number of outcome is 200. Out of those, number of outcomes in which 2 heads are coming up is 72. So from here we can see 2 heads as the outcome is 72 times. So here we have written so. Therefore, the probability of 2 heads coming up is equals to, so number of favorable conditions. What is a favorable condition? 2 heads. That is equals to 72 by total number of outcomes, that is 200. So, the final probability of getting 2 heads when we toss again will be 9 by 25. Question number 5. In an organization, selected 2400 families at random and surveyed them to determine a relationship between income level and the number of vehicles in a family. The information gathered is listed in the table. So what we can see here is these are the monthly incomes of the families. So a total of 2400 or 2400 families have been surveyed. These are the different ranges of monthly income and these are the number of vehicles per family. So the number of families who are having zero number of cars or no cars are these. Families having 1 car are these, and the families having 2 cars are these. And the families who have more than 2 cars are these. Again, they have differentiated the values. That is, the families having no car and their monthly income is less than 7,000 is 10. The families having no car and their monthly income is between 7,000 to 10,000 is 0. There is no such family. Number of vehicles is 0, that is no vehicles for a family, but their income is between 10,000 to 13,000. One such family is there. Again, there are 2 families who have no vehicle, but their monthly income is between 13,000 and 16,000. Similarly, we can say from here that families who have 1 car and their monthly income is 10,000 to 13,000 is 535. Or families having more than 2 cars and their family income is between 10,000 to 13,000 is 1. There are 88 families who have more than 2 cars and their family income is between 16,000 or more. So like this we can read the given table. Suppose a family is chosen. Find the probability that the family chosen is number 1, earning 10,000 to 13,000 per month and owning exactly 2 vehicles. So both the conditions should be satisfied. Second one is earning rupees 16,000 or more per month and owning exactly 1 vehicle. So from the given data we can see the total number of families surveyed or the total outcome is 2400. For part 1, since the name is so long, let us write down as an event. So let the event E is equal to families earning rupees 10,000 to 13,000 per month and owning exactly 2 vehicles. That is the statement. Let this be the event and we mark it as E. Therefore, we can say the number of outcome for E. So the number of favorable conditions for this event E will be how much? So 10,000 to 13,000 right here, and they will own exactly 2 vehicles. So that is right here, exactly 2 vehicles, and 10,000 to 13,000 will be 29. Hence we can write the number of outcome for this event E will be 29. Therefore, the probability of event E will be total number of favorable outcomes, which is 29, and total number of outcomes or families, that is equal to 2400. Hence, the probability of E is 29 by 2400. For the second part, we have earning rupees 16,000 or more per month and owning exactly 1 vehicle. Let this be our event E. Therefore, the number of outcomes satisfying this event E will be 60,000 and more and owning exactly 1 vehicle. So, they will own exactly 1 vehicle. So, right here, 579 is the number of outcome of the event. Therefore, the probability will be number of outcome or favorable outcomes, that is 579 by total number of outcome, that is 2400. Hence, the probability will be 579 by 2400. The probability that the family chosen is earning less than rupees 7,000 per month and does not own any vehicle. So, let E be the event where the families are earning less than 7,000 per month and do not own any vehicle. Therefore, number of outcomes for such an event would be 10, because the families are having a monthly income of less than 7,000 right here, and they do not own any vehicle. So, 0 number of vehicle, that is number 10. Hence, the probability of this event E can be written as 10 by 2400, as the number of favorable outcome is 10 and total number of outcome is 2400. Hence, the probability is 1 by 240. For the second one, earning would be between 13,000 and 16,000 per month and owning more than 2 vehicles. So, what we can see from here is monthly income between 13,000 and 16,000 and owning more than 2 vehicles is this 25. Hence, we can write the event is the family earning 13,000 to 16,000 per month and owning more than 2 vehicles. So, number of the outcome of event E is 25, and therefore the probability will be 25 by 2400, that is 1 by 96. Lastly, find the probability of the family owning not more than 1 vehicle. So, they have not given any monthly income as the parameter. We just have to see owning not more than 1 vehicle. So, here is 1 vehicle. Not more than 1 vehicle means that less than 1 vehicle or 1 vehicle. Either the families are having 1 vehicle or the families are having either no vehicle or 1 vehicle. Therefore, we can say that all these families under this table or column are applicable. Also, the families under these column are also applicable because these families do not have any cars and these families have 1 car exactly. But these values are not more than 1. That means not more than 1 is neither 2 not more than 2. So either 0 or 1 car should be there in the families. Hence we can write down if the event is families owning not more than 1 vehicle. Therefore the number of outcome for this particular event would be number of families having no vehicle and number of families having 1 vehicle, as because we will not choose the monthly income as it is not the parameter. So the families having no vehicle are these. So 10 plus 1 plus 2 plus 1. So all these are having no cars, and now the families having 1 car are 160 plus 305 plus 535 plus 469 plus 579. So we'll take the sum of all these families and the answer is coming out to be 2062. So this number of families have the outcome for the event E. That means the families were not owning more than one vehicle, either less or no vehicle. Hence the probability for this event E would be 2062 by 2400. This is the total number of outcome for the event E and this is the total number of families. Hence the final probability will be 1031 by 1200. Thank you everyone for watching. Hope this video was useful. Take care. Bye bye.